Hello students, welcome to the new video of this series of object-oriented programming. Now in this video we will go into further details about what is an object, what is a class, how are object and class related. In the previous video we had a brief overview about object-oriented programming. We understood what a procedural programming was and why people switched to object-oriented programming. In this video we will focus a little bit more in detail about objects and classes. What are objects, what are their characteristics, and we will focus more on the intricacies of object-oriented programming. So let's begin. So before we go into this object-oriented programming and objects and classes, first we can understand what basically is a program. So what do we mean by a program? So for any interaction, say there is an interaction between two humans. So to interact two humans, they will need a language. So similarly, two animal species also use any language to interact. Birds use languages to interact. Same way, for a human and a computer to interact, they will need some language. So a human computer interaction is not possible without a mutually agreed language through which they can communicate. So that language is called a programming language. So if two humans communicate in English, maybe a computer and a human can communicate in C, Java, these kind of programming languages. So the construct of a programming language is called a program. So a program is a set of instructions that is passed into the computer, and the computer understands it, and the computer then responds with some particular information or data which the human can understand in a human readable format, and that's how the communication happens, and that's how the applications work. So in a program there can be many things, like there can be data in a program, then there can be function. We'll come to know what all these are. Then there can be various states in a program. So basically the three aspects are: the data is the information basically that is passed from the human to the computer and back from the computer to the human. The function is basically a set of instructions that is sent to the computer or programmed into the computer, and the computer will follow this particular set of instructions for doing a certain task. For doing any other task, we may program it to follow another set of instructions. So these set of instructions or functions or code blocks is what the computer follows and it performs. And a program can have many states. So these states are dependent on the data. So these states are the values of the data. So basically these are the data values at any given instance, so that determines what state the program is in. Apart from that, let's say we see a few basic examples of a program. So a basic program is, say, a calculator. So we have a calculator application on a mobile. There are various buttons in a calculator. We perform certain tasks. Say for example we want to add some numbers. Say we want to add 2 plus 7. So we enter 2, then we enter 7, and the computer responds with the answer. So what it does behind the scene is it runs a program. It takes the input from the user. So this input initially is 2, then it stores that input in memory, and then since it is a calculator program, so it waits for an operand and another number. So the operand here is plus, then another number is 7. So all these inputs are collected by the program, and when it sees the logic of all the inputs collected, and then it sees the logic of the function that it needs to perform, then it performs that set of functions and then returns the output. So it calculates the output itself first, so which is 9, then that output again is delivered to the output screen. So this is a basic behind the scenes working of a calculator, very simple stuff. Similarly, we can say another example can be of, say, a list, a to-do list. So suppose many of you have already used some kind of to-do list, where either on the mobile or on the computer, where there's a checkbox and a to-do item that needs to be done. It's kind of a checklist, and then at the base there will be some input box where you enter some to-dos that you need to do. So in this case, what happens is there is a program that runs behind the scenes for this. It takes the input of your to-do, the new to-do. It already has some list you already added earlier. Then as soon as it takes the input, so it maintains internally a list of all those to-dos that you already entered, and then when you enter a new to-do, it adds up to that list. And as soon as this list is changed or modified, then this sends back to the screen the refresh list. So it refreshes the list. So the list that was added here in its memory, it gets displayed in a checklist form here on the screen. So all this activity is done by this program. So now suppose now you are checking some list. So you check this list, you click on it and you check this list. So what it means for a human is that you have completed this task and you have checked it, so it should no longer be in your checklist. So this happens as soon as you check, an input is sent to the program saying that, identifying this which of the to-do item has been checked. So say for example this is number 1, 2, 3 and 4. So it identifies that okay, number 2 checklist has been checked. So program gets the number of this, and then it goes to that list that it maintains, and then if this is the number 2 list, then it deletes the item from this list which is corresponding to the number 2 item. Then this list will contain only 3 items, 1 item is less. Again this list will update the program that okay, I have removed 1 item and I am ready now. Refresh. So the program will then again refresh this list back again. So here in In this we will not have this list item, and we will have only 3 items. So this is one kind of a program. It's a little more complicated, but it shows behind the scenes what exactly happens, how the program is able to do certain tasks, and it can be useful for a human. So a programming language is the language in which this program is written, and usually it's the humans who write the program, who instruct the computer to do certain tasks based on certain conditions, certain scenarios. And the program itself, machine itself, uh, is called a dumb machine. So but in this age now we have artificial intelligence, but without AI, all these programs and machines were called the dumb machines. They won't do anything by themselves. They will just do whatever is instructed to them. They will check all the use cases. They will perform actions based on certain scenarios they encounter as per previously instructed or written down in the code. So all that action they do is based on what code is written into the program. So here in this case, we can see that the the three aspects, the data, the functions of this program. So what in this case, what can be the data? Data is definitely the to-do list items. This forms the data. Together they form the list. So it can also be said as data set, which means a set of data. And functions here is the written set of instructions. So for example, one function can be to refresh the list on screen when any change is being made. So you have added a new list, then it processes that list and then it refreshes to reflect the new list with added item. If you have deleted, then it again does the same. So one function can be to refresh the list on the screen. Another function can be to update the data set. So this is this data set that it maintains in memory. This portion is just the display. It is just a display of list. It is not the core data. That is the data that is used is from this list, which it maintains behind the scenes. And another function can be to get user input or user to do item from the input. Then there can be states. So states can be the list state. So state is basically the value of the data at a given point of time. So when you have not added a new list, so the list state will have say 1 2 3 list. Then when you have added one more, then the list state will correspond to 1 2 3 4, this kind of list. So the list state will change. So as soon as user interacts and there is a manipulation in data, the states of the program will keep changing. So now we have seen basically what is a program and what it can do in a simple way. Then now we can focus on object and classes. So as discussed in the last video, objects are basically digital entities similar to what we have in the real world. Like there can be a user in the real world, there can be a dog object, there can be a shape rectangle, They can be a rectangle object. We can calculate the area of a rectangle by having a rectangle object. So suppose we have an object called dog. It's not an actual physical dog, but a digital entity, digital representation of a dog. So if we have that kind of an object, then what all features it can have? So it can have certain attributes. Say for example, if the dog is there, then dog can have a name, dog can have a breed, and dog can have age. So these things are called attributes, which basically define the dog. Then dog can also have states, like program states. So basically, if you change the name of the dog to some other thing, that the dog state of the dog will change. So it will have attributes and state. So if the dog is, say, 5-year old, and then you change the age to 6 years, then the state of the dog object changed. Apart from attributes and state, then it will have functions or methods where it can take certain actions. So it can take an action like eat, it can bark, it can sleep. So these action oriented words which you are seeing, these are the actions. So these are also called functions or methods for an object. So basically, if we represent it in a way in which the industry represents them as an entity, so we can have something like this. We can have a name of the object, we can have the title, and we can have these attributes like this. Then we can have methods here, all these methods. So attributes, methods, and the name of the object. This name is different than the name. This name is an attribute. This is an object classification name. So we'll come to the class also. Apart from dog, if you can see, if we take an example of a rectangle is not a physical entity, but it's kind of a understanding of shapes. So it's a geometric shape. So what can a rectangle have as an attributes? Rectangle can have length, it can have breadth, then what it can have area. So which area also is not a unique attribute, it is actually dependent on the length and breadth. So it's not an individual attribute. So it's, we can ignore this area also. We can calculate the area through functions. So it can have a function which can say that calculate area. So this will calculate the area of the rectangle. So similarly, we can write the rectangle object like this. So as we saw in the real world, objects were like concrete things which had dimensions which we can touch and feel, and not abstract things. So similarly, these objects these are called software objects. They are concrete entities, not concrete in a physical sense, but concrete in a digital sense. So how are these objects created and how they are managed by a program. So a program does not know what is a rectangle object, what is a dog object. So to let the program know about these objects, we have to classify these objects. So that's why we have class. Class is short form of classification. So it classifies the object. So here whatever definitions I have shown you, these are exactly the same things what a class will contain, because it is just a classification. So if we have a class rectangle, then the class will have these attributes mentioned. This class will have area, class will have instructions how to calculate the area, but still class is just a blueprint. So it will not have any concreteness in a digital sense. So it will not have any actual values of length, breadth and area. A class will just provide a plan, a blueprint, a structure. So like suppose for example, you want to build a house. So to build a house, you can just go about randomly hiring people to build your house and getting a land and doing things haphazardly. So every day, every time someone will come asking you where to build this wall, where to place this window, when to place the roof. All these kind of nonsensical building activity will happen, and the house that you will build will be almost like a terrible house which you won't be able to live in. So in that case, what we have here is a blueprint. So if you see, every house, if you see, has got some plan, some maps like this. So you have floor plans, ground floor, first floor, all the plans with actual width, actual distances measured exactly. So when everything is measured and structured and have a foolproof plan or blueprint, then with this plan, or you can call it a blueprint. Blueprint is called because in earlier days these were printed on a piece of paper with blue ink. So all these markings were man-made, manually marked with scale in blue ink earlier. So when this paper appeared, it was called a blueprint. But right now all these plans are just printed in computer. So once you have this plan, then with this plan, if you give it to the engineer, civil engineer or contractor, he can build the exact house as per this plan. If you give it to another engineer, then he can build a similar house, same. There won't be any issues. So to whoever you give this plan will build a similar house according to this plan. And you can also build in the same plan, you can also build multiple houses. So if you see row houses that are built one after the other, so these houses are just constructed based on a single plan. It's the same structure, same plan, same foundation, everything is same. So one after the other, in row houses people are building houses which look exactly similar. In the same way, class is also a kind of a blueprint for an object. So here in this case, if you call house as an object, then this plan or blueprint of an object can be termed as class in a computer sense. So if you have a class called say dog, then if you have a class dog, then similarly, like houses, you can have multiple objects created. Like this, you can have multiple objects that is based on a single class called dog. Similarly, you can have a class called rectangle, and you can have multiple rectangle objects. So they can be differentiated. They can have different attribute. So if you can see, here the length of the rectangle is more, here the length is less. So each of these objects will have a uniqueness about them. So otherwise, if suppose these two rectangles, if suppose their length and breadth both are same in these two rectangles, so it will be nearly impossible for a computer to recognize which object is which and which object to consider. So as soon as you instantiate an object, instantiate means like you create a house from a plan, you create a house. So this takes a lot of time, maybe months or years, but eventually the house will appear and the house will look exactly the same based on the plan. But here what can happen is, in this class rectangle, it has a structure, but the attributes can vary. So in this same class rectangle, you can have almost identical two rectangles which are completely identical, whose length are equal, whose breadth are equal. So there is no way to uniquely identify them. Then you can have a third rectangle with different attributes, its length is greater, like that. But in case when you have the attributes same and exactly similar objects are created, so then you need to have a unique identity or a unique identifier for each kind of class objects. So unless you have a unique identifier, you will not able to identify, the computer will just not be able to identify which object is which. So this is a must. So what should an object have? It must have a unique identifier. It can or cannot have attributes. It can or cannot have methods or functions. So the object can take certain actions, it can do some job, and these, so unique identifier can also be one of the attribute, like an ID of the object. So it maintains an unique ID, like the Aadhaar ID which we have, or the unique ID. And it can have a state. State is just the value of these attributes. So the value of attributes at any given time, this is state. So yeah, I think I've shown enough examples of a class and object. I hope this is clear, and this video is getting longer, so I will just stop it here, and in the next video I will just try to get more in depth about creation of class, creation of object, and the four paradigms that are there for object oriented programming, that is encapsulation, abstraction, inheritance, and polymorphism. So those are not very simple things. They're a little bit more complicated, so it will take some time to grasp. But I thought that students should have a thorough idea of what basically a program does, what is a program, what is a class, what is an object. Unless you have a thorough idea, just learning about abstraction and inheritance and polymorphism will just not make any sense. And I don't use slides also, because I don't believe that slides are really helpful in understanding or in gaining some knowledge in deep thinking. I feel that once the slide is there on the screen, then you're understanding something. Once the slide is gone, then all your understanding is also gone. So I will focus on just creating diagrams and blackboards, and hopefully you will like my approach and my efforts. So thank you for watching, and I'll be uploading a next video getting in depth about classes and objects very soon. Thank you.